Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to take a look at your Unit 7 introduction. Unit 7 is on combination circuits. And what a combination circuit is, we take a series circuit and we take a parallel circuit, and now we combine them into one circuit that we call a combination circuit. So a very traditional combination circuit. I have a battery with voltage V. I have resistor R1. And then I have resistors R2 and R3 now in parallel, and I have resistor R4 in this combination circuit. So what we can do, we can actually first take a look at R2 and R3, which are in parallel, and we can solve for the equivalent resistance value. So in this example, REQ is going to be equal to R2 multiplied by R3 divided by R2 plus R3 to get the overall equivalent resistance value of those two resistors in parallel. We can redraw the circuit now, as we see here, R1, the equivalent resistance we just calculated, and R4, same battery voltage V, and now we have a direction of current flow. So what we've done, we've converted this circuit, a combination circuit, into a traditional series circuit where we can solve for the equivalent resistance, the current, and then the voltage drops across each of the resistors. So please remember the rules. For a series circuit, the equivalent resistance REQ is equal to R1 plus R2 plus R3 plus R4 if we were to have four resistors in series. The sum of the voltage drops have to add up to equal the battery voltage. So remember, we identified VR1, VR2, VR3, and VR4. If we were to have four resistors in a series circuit, add those values together, they have to be equal to the battery voltage. Current is the same everywhere in a series circuit. So the current is the same through R1, through R2, through R3, and through R4. Power supplied and power dissipated, when we do calculations of what the total current in the circuit is multiplied by the battery voltage, we would get the power supplied. And then each of those resistors, remember, are going to dissipate heat, dissipate thermal energy, and we're going to calculate those power dissipation values, and when they add together, that's going to be equal to the power that is supplied by the circuit. In a parallel circuit, remember, the voltage drops are the same across all of the resistors. This time the current is going to change. Remember, we referred to that common point of connection as a node, and at each resistor location we have what's called a branch current that flows through the resistor. And what ends up happening, each of those branch currents will now add together to be equal to the total current in the circuit. Equivalent resistance, a little bit different, two different expressions, algebraic formulas. Only two resistors in parallel. Remember, R equivalent is R1 times R2 divided by R1 plus R2. If you have more than two resistors in parallel, 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3, for example, if we were to have three resistors. Power supplied and power dissipated works exactly the same as it does in a series circuit. So the combination circuit that we took a look at right here, we're going to now use the rules we learned for a series circuit, and we're going to use the rules we learned for a parallel circuit, put them together, and what our ultimate goal is to get the circuit down to the simplest value, which in our case here is going to be a very traditional series circuit where we're going to just have three resistors in series, and now we can go ahead and solve for the equivalent resistance, the current in the circuit, which is now going to remain the same, as well as what each of those voltage drops are. All right, thank you. Have a great week, and we'll see you next week.